All right, so I'm doing, how do I hide? Hold on a second. How do I get rid of this stuff here? Give me 1 second. There we go. All right, so we're gonna do hydronic snow melting. We have two brands, basically one brand hydronic, one electric. So we decided to do the hydronic version. The electric would be, of course, the Danfoss. The hydronic's going to be ComfortPro.
Recording these?
You there?
Are these being recorded?
Oh, yeah, I have no idea.
Yes, this is being recorded.
Okay, I'm actually right next door to it working, so
All right.
whenever you have a minute, if you wanna.
You
Go
ready?
ahead, Dan. Yeah,
Oh, you
go
ready?
ahead, buddy.
Okay. So we're going to go over the system considerations. We're going to go over the classes, the different classes they have as far as 1, 2, 3, residential, commercial, and so on. We're going to go over some layouts, drainage, of course, and then boiler piping. Very, very quick into boiler piping because this is just going to be a basic snow melt presentation. And my boiler's kicking on over there, so now I got a competition here. So applications for snow melt. So of course, sidewalks, access ramps, loading docks, stairwells, parking lots, any kind of garages, vestibules, bridges and catwalks, or any area that's difficult or inconvenient to maintain using conventional snow and ice removal methods, which would be chemicals, salt, things like that. When we design a system, the main things to take into fact is going to be, of course, the outdoor temperature, the wind speed, the area that you're going to melt, your climate, the rate of removal, of course, the cost of what it's going to be to run it, and your local codes if you live in a neighborhood that you even have any of those, which you may. So ComfortPro, that brings us to ComfortPro. Combines PEX pipe technologies with time-proven distribution and control options, helping to design, construct, and deliver outdoor radiant applications, promoting safety, security, accessibility, reliability, and extended surface life. So that's pretty important because you use this instead of using harsh chemicals on the concrete, which of course eventually you know what happens. It pits it and erodes it. When you're using salt or ice melt, some of that stuff's no good. A lot of it, I mean, I don't believe in any of it, but that is what it is. Designing the system, you have to carefully design it. There's a lot of factors that I've learned that you need to take into consideration when we do a project. First thing, I didn't know there was this much to know about snow, but the density of the snow. It's very important because snow, it changes, it changes between temperatures. So most commonly forms at a temperature between 40 degrees and -10. Depending on what temperature it forms, snow can be very dense or less dense. So that's when you get those snowfalls where it's like powder, and then the ones that you can pick up and make an ice ball and throw at somebody. The temperature of the snow, new fallen snow is not much different than the outside temperature. Outside temperature can vary widely, can vary as well. Without knowing the outside temperature in advance, it's impossible to determine how much snow can be melted with a given amount of energy in each time period. Wind is a very critical element also. Sometimes there's no wind present during a snowfall. Sometimes wind gusts of 30 to 40 mile an hour. Strong winds steal BTUs from a slab faster than outdoor air temperature. The presence of buildings, landscape, or even snow fences reduces the negative effect of wind on a snowmelt slab. Even the control strategy plays a role in the effect of wind. If the system is controlled by an on-off system, the effect of wind is often reduced because snow accumulates on the slab and shields the slab from the wind. So a very important part of all this is going to be insulation. Of course, it's going to be your first barrier down. So it requires a 2-inch, the blue ground insulation, like the thick, I know you've seen it on job sites, the 2-inch blue ground insulation barrier to ensure quick slab response time and energy usage. Drainage, you would never think drainage would be something important, but you need to have the drainage there in case you have high and low spots in what you're trying to do, and then it collects ice or collects the water, and then what has to happen is it has to go away once it melts. So that's very important. I did learn that. And of course, the PEX pipe it's not a structural type of pipe, so make sure your building codes will accept it to be used, and it's not going to jeopardize any of the foundation or the concrete or anything you're putting it in. Of course, the site. So here's where we're going with the material that you're putting on top of this. It can be used snow melted concrete, asphalt, interlocking brick pavers. In addition, surface material is used, asphalt, gravel, paving stones. The supplied temperature must be increased to compensate for the additional heat losses in those applications. Frost protection, of course, anything you put in, it has got Dow frost, I don't really know what that is, but antifreeze is what you need to use for heating systems. In the outdoor, any outdoor application, period. Any questions so far? Okay. Here's the chart that you can go over. The ground insulation, as we said first, is a very important key to all this, because what happens is you put that down, and it's not an energy conservation thing. The benefits are it reduces the back losses and warm up time, and it's quicker melting once the system is started. That's what the insulation is going to do. It's going to reflect it back up to melt better. Like I said, it's not really going to save you any money, because face it, you're outside, you're going to get, it is what it is. It's important to use that insulation. Like I said, blue 2-inch thick insulation. Okay, so performance and limitations. So, there would be a limitation, but while every possible condition must be considered to ensure the proper design of this snow melt system, as we went over, temperatures, excessive wind, blowing and drifting, unusual high snowfall rates may cause this best system to fall short of their goal of total snow and ice removal. The requirements, there is a chart. ASHRAE has a chart on total BTU loads on what we're doing, on your local weather conditions combined with construction considerations, including slab and edge insulation, tube spacing, flow rates, temperatures, input and returning, ensuring predictable performance characteristics for slab, tubing, and your heating plant. These pictures, I'm sorry, they're a little blurry, but they couldn't get any better. It just wouldn't work. But this is a typical during installation. So you see during on the left, you see after on the right, how it's working, how it's melted out that snow. This right here, as you see the tubing, you see the insulation down, very important. You see the rebar on top, you see it being secured to it, and then you see the spacing. This is, during installation, another picture. As we talked before, classes. So there's 1, 2, 3. So your first class is going to be residential. Okay, residential driveways, walkways. The rate of heat delivery to the surface in general, the range of 80 to 125 BTUs a square foot, depending on location. And you'll see the chart in a little bit. Class 1 systems often allow a layer of snow to accumulate during a heavy snowfall, especially if the system is manually controlled and starts from the cold. The snow layer is actually beneficial because it acts as an insulator between the heated pavement surface and the outside air, reducing both evaporation and convectivity losses. Evaporation of the melt water requires much higher heat input. So that's why drainage is coming up again. Like I said, very important. Class 2 is going to be more commercial. So commercial, but not as Class 3 is going to, you'll see, is going to be really important commercial. This is important, but except it is sufficient for most retail and commercial paved areas that must be kept clear of snow. The rate of heat delivery to the surface is typical in the range of 125 to 250 BTU a square foot, depending on location. And class 3 is very high priority, as I said, very important. So helicopter pads, toll plazas, parking areas, anywhere where there's going to be a lot of people that could risk getting hurt or something, happen. It's designed to ability to melt all snow as fast as it falls and quickly evaporate the melt water from the surface. Generally require heat delivery rates of 250 to as high as 450 BTU a square foot. Now, this chart's a lot bigger than this. This is just what condensed it into. Baltimore. So I got with Todd from ComfortPro, and so they say Baltimore is going to be in between, say, Philly and DC with their numbers. I don't know why. Todd said we don't have the number, but I'm sure we can go and find it. But he said, we did not have the information. So this is class 1, 2, 3, as you see the chart. That's what you're going to base your sizing off of. Typical residential layout. As you see, coming from the garage, that's probably where your manifolds are going to be. That's where it's coming from. It goes around, of course, to your house where your driveway would be, comes around to a parking pad, goes out to the street and stops. That's, like I said, typical residential layout. There's an actual picture of what that picture could have looked like in live time. You see the insulation again down. You see the rebar. You see the tubing being secured to it. Here's two more pictures of installation. As you see, same difference. You see everything going the same way. The insulation. I don't see any rebar on these two. But you do see, we'll talk about in the next couple frames, there's some pieces that ComfortPro make to space the tubing out exactly what it should be. And you'll see that in a couple slides.
Hey, Danny.
Yes.
Can it be with concrete and asphalt or just concrete?
It can be with everything. I'm going to show you now. We're going to go through concrete. We're going to get to asphalt. Yep. It's coming. Any more questions so far? All right. So here's your concrete, like your cutaway of the concrete install. So cement is poured over compacted soil or fill, as you see. PEX tubing is installed using a wire mesh or rebar, holding tubing in place until embedded. High density insulation, of course, as we talked, underneath. And then you can do vertical insulation, and you don't have to go up too far, but like we did, I don't have outdoor radiant, but like in the garage, we went up like 4 inches on the side wall with insulation, just to make sure we keep that heat down as low as we can to the ground. And then this is the basically another cutaway of that. As you see, it's just a better view, a drawn view. As the same thing. Tubing's embedded in the overpour. Always wise to install high density insulation, of course, as we talk about, period. And like I said, that's for the heating. It's not saving any money. There's that part I'm talking about right there. That part eliminates any guesswork in the spacing of the tubing. That actually has grooves in it where you put it down and you actually snap the tubing into it. Makes the job goes a lot quicker. If not, you're you're zip tying tubing to rebar, and I'll tell you what, if you've ever done that, that's a terrible job. Paving stones. So here's another example. Paving stones, concrete, brick, or stone pavers. So here's the cutaway of that. PEX tubing installed in the sand bed, held in place with wire mesh or rebar again. Minimum 2 inches of sand cover should be over the tubing. High density insulation board, of course, as we talk again, period, on this picture. And then the next picture is going to be another cutaway of the same thing, just a little bit different drawn. Asphalt, here you go, Aaron, asphalt. So cold pour and hot pour. Hot pour is going to be next. I didn't know there was really, I don't know what the difference was until now. So the cold pour, so the first asphalt lift is backfilled manually over the tubing. It's very important that you don't mess too much with the tubing because it is gentle, it is fragile, and you could put holes in it. If you have concrete guys running around with their spiky shoes on, you can't have any of that. Like that cannot be done. You need to monitor these jobs. Asphalt temperature of the lift is in excess of 240 degrees, and cool water should be circulated through the tubing during the pour. Final lift is applied by a machine. The next one's hot pour. Asphalt. Wire mesh, rebar again, holding the tubing in place in a sand bed. Minimum of 2 inches of sand should be over the top of the tubing. A paving machine then lays the asphalt in the usual manner, just like anything else. Right there, like I said, a machine, not spiky shoes, period, none of that stuff. Aaron, did that answer you right there, buddy?
Yes, sir. Thank you.
Okay. And as we talk drainage, so like I said, high, low spots, drainage needs to go somewhere. Once that snow and ice melt, it needs to go to something. So we can put a trench drain is actually ideal. You know, whether that be commercial trench or residential trench if at home, for sidewalks and everything like that. So as you see here, I mean, they have it covered up. Now you can, the trench drain pretty much comes with a cover on it. I don't think you have to use 2x4s anymore, but I know Sioux Chief makes something that it already has, you can put the cover on it, and there's your, you know, inlaying of the trench. Okay, so piping. So just real quick on this. So how to run the radiant. So everything has to be ran by a boiler, would be preferable. So here's your one temperature, primary, secondary on your boiler piping, just like you'd install a boiler. A pair of close tees, you know what primary and secondary are. Not more than 1 foot apart. Portion of the boiler water to be diverted into the secondary loop. Pump 2 to be pumped through the snowmelt system, as you see there. Return water from the zone is partially diverted back to the primary loop with a glow valve between the tees. In non-condensing appliance applications, glow valve must be set to keep the boiler return temperature above 140 degrees during the operation of heat exchanger and burners from condensation. Second way to do it, variable temp with actually a snow melt relay, offered by ComfortPro. It's a 3-way or 4-way valve providing exact mixing temperatures based on supply sensor feedback on secondary loop from the outside supply sensor. Control can also protect the non-condensing boiler heat exchanger and burners by monitoring minimum return water temperatures by adjusting the mixing valve to hold back enough supply hot water to remain above 140 degrees. Heat exchanger piping. This is kind of real cut and dry, as you see. Boiler again, like I said, everything's we're running with a boiler. Glycol, there's the glycol again, the antifreeze made for boilers though, so we're going to call it glycol. And you see the manifolds for the snow melt system, you see the controls. Then, you know, we have a commercial dedicated snow melt system, boiler right to the snow melt, of course, filled with glycol again. Like I said, all this stuff outside has to be for freeze protection. As you see, you know, return in and out. And then this picture, of course, is great to have because it shows you the snow melt So it shows you ComfortPro, it shows you the Grumpus on here. The boiler, I'm not really even going to say what that even is. I don't even know who that is. It ain't ours. It looks like something. I probably wouldn't put that one in. I'd put ours in. But you can see everything laid out here as a piping diagram for certain systems. And that's going to be it unless you have any questions. That's all I got.
Hey, Dan.
Yes.
It's Dave. Can you back up 2 slides?
Yeah, I got to figure out how to do that. I'm not trying to be funny. To that one?
Yep. So
Yeah.
that's showing a dedicated system where you would have glycol in the entire system.
Correct. Yes, correct. Because all you're doing is that snow melting outdoors. Yes.
Right. So one of the things you need to be careful of when you do that is you can't hook a normal fill valve up to that, because if you get a leak somewhere at a fitting, at the boiler, out in the field, you're then going to feed fresh water in and dilute your glycol mixture, and then you risk freezing it up.
Okay.
We actually had a job that did that. So anytime you do this, you have to put a glycol makeup feeder in. They make them. It's a tank with a pump.
Okay. Okay.
Tank.
Yeah, that's great to know.
Just
Yeah,
something. Anytime you've got a glycol system, you should not be using a typical fill valve to
regular feeder.
Yeah.
A regular fill valve.
Yep.
Okay, great. Yeah, that's great to know.
Hey, Dave, you might know the answer to this question. So the Dalfrost glycol, is it only approved for Dalfrost, or you can use any food grade?
Oh, I've never heard of that.
I've never heard of it either, Jason. I don't know what that is. That's probably some brand they carry in.
It's just a brand of food grade.
Brand. I think it's a brand they carry somewhere.
Any hydronic antifreeze should work.
Yeah.
Well, I had a system a few years ago that actually had a like a calcium buildup on the inside of the tubing going outside.
Uh-huh.
That was really pain to air blast out of the piping and get it so it actually circulated again. So I was wondering if
it was a glycol system.
Yeah.
Yeah. Typically, those antifreezes, once they're put in, they will start to degrade over time, and they do make additives that you can put in, and they have test strips. So those antifreezes typically have oxygen scavengers in them and corrosion inhibitors.
Yeah.
And you need to test that antifreeze yearly. Excuse me, to make sure it's still effective.
Absolutely.
That's a good thing to point out then.
One other thing I'd point out, we have a lot of other options on snowmelt controls with Techmark.
Yes. I didn't want to go into everything, but yes, you are totally
No, not. I just wanted to mention, like, we could do a whole nother training on the controls portion of it.
Yeah, absolutely.
Which would probably be a good thing to do, and kind of combine this with that. But yeah, good job.
Thank you.
Nice job, Dan.
Thank you, Mary.
Well done.
Thank you,
Any
guys.
other questions from anybody?
I was going to say, is that it? And of course, all this stuff, Todd can help you, direct you to who can help size these, the loop CAD, all that stuff. So Todd's he's very good from ComfortPro to work with.
Great. Can you send me your presentation? I'll put it up on the drive.
Yes, absolutely.
Great. Thank you.
Thanks, Dan.
Excellent
Hey,
work,
guys.
Dan.
Hey, I have a question.
Yeah. Oh, you would at the very end.
It's not presentation related.
Oh, okay.
I wanted to see if anybody would be interested in doing some sort of like happy hour